Lesson 9.1b, Measures of Central Tendency. We're beginning a chapter that is dealing with all different kinds of data and statistics. The measures of central tendency you have already looked at least last year. They are known as mean, median, and mode. To find the mean of a list of numbers, you add them all up and divide by the number of numbers in the list. The median is the middle value, like the median is the middle of the highway, it's the middle of value. So you have to, of all the lists, the middle of all the lists, you have to put the numbers in order from least to greatest and pick out the middle one. Well, if there's an even number of numbers, there's not one in the middle, but there's two in the middle. So you take the two in the middle, add them up, and divide by 2. The mode, I always say mode, M-O, because it begins M-O, most often, the number that's there, the most often. The mode, there can be more than one mode, or just one mode, or even no mode, if there's no number that stands out more than the others. If there's no mode, you actually have to write the words no mode. Don't leave it blank, because then it just looks like you don't know what to do. But if you for sure you know there's no mode, then you should put no mode. Also, this is pretty important. Today we're gonna split this over a couple of days to make sure you have it down pat, because it's very important. Today's just going to be cut and dry, find mean, median, and mode of these sets of data. But tomorrow it's going to be more of this stuff. So this is pretty important. Okay, so right here. Different circumstances determine which measure of central tendency is most appropriate to describe the set of data. That's going to be in tomorrow's homework. Which measure of central tendency is the best description of the data? So it's telling us the mean is most useful when there's no extreme values. Anybody know what an extreme value is? What does the word extreme mean? Logan? Big. Something's extreme. So extreme, I'm trying to think of a TV show or something that would have extreme. Is there one that's called Extreme Makeover? So what's extreme? Anybody know what Extreme Makeover is? What is it? What's that? So they take the entire insides of the house out and start over, right? So that's extreme, something to the extreme. Well, our extreme can also be known as an outlier. Now that word kind of rang a bell last period. You guys hear of outlier? Mr. Grivey talk about outlier. It's a number that's pretty far away from the rest of the list. So at my expense, I'm going to give you an example of an extreme. So let's say in this classroom, we wanted to do the mean of the ages in here. Okay? So how many, is anybody in here 11? Not 11, that's not what I meant to say. Anybody in here 12? Okay, so we have some 12-year-olds. What about 13? Okay. Is there anybody 14? Okay. So we've, you guys are clustered. That's another vocabulary word. You're clustered around 12 and 13, right? 14, 12, and 13. Well, if you put my age in the list, I would be an extreme value. I know I'm not that much older than you. Watch it. But I would be extreme because I'm not anywhere near 12 and 13. Okay, so I'm an outlier or an extreme value. So that would probably mess up the mean. We're going to do an example that is a great example that shows you where an extreme number messes up the mean. It like pulls it away from where you think it should be. So if there's an extreme value, you probably don't want to use the mean. The median is most useful when the data has few extremes with no big gaps in the middle. What's gaps? What's a gap? a blank space where there's a section where there isn't any numbers. So if there's gaps, you don't probably want to use the median. And the mode is most useful when the data has identical numbers. So you'll have to decide each time which one makes more sense and is a better descriptor. But again, that is more like what we're doing tomorrow. So let's look at an example that they have already done for us. It says the following are ages of relatives staying at your home: 16, 38, 8, 2, 92, 36, 10, and 2. So all those people are staying at your house. How many people are staying at your house? How many are there? What's it say? Did you count them? How many are there? 8. There are 8 of them. There are 8 people. So just like this in your homework today, I'm going to ask that you make it very clear and label that you're doing mean, median, and mode. Okay, so you'll put mean, and you add up all the numbers. They add up all the numbers and divide it by 8. So their mean was 25.5. 25.5. Now, was there a 25-year-old in the home? No. So mean doesn't have to be a number that's actually in the list. All right, median. For median, you got to put the numbers in order from least to greatest. So it looks like we did this. You're going to have to do that today. Where you write median, you're going to take the numbers, you're going to put them in order from least to greatest, kind of spread them out like that. Since there are 8 numbers, there's not 1 in the middle. So they have to look at these 2 in the middle, 10 and 16. Add those up and divide by 2. So the median is 13. Was there a 13-year-old in their house? No. So the median doesn't have to be a number in the list either. Mode. Mode, it says the number 2 occurs twice. Okay, so when you look at them in order, there's 2 2s. Nothing else has 2. So 2 is the mode. Why would there be 2 2-year-olds? What do you think? Must have been twins there. Okay, so the way that they labeled this makes sense. It's age. So the mean, 25.5 years, median, 13 years, mode, 2 years. So you will label your answers as well. So you add them all up, divide by how many there are for the mean. The median, you put them in order, pick out the middle one or the 2 in the middle and add them up, divide by 2. Mode, which one's there the most often. Okay, so we're going to do one now. We're going to do 2 actually. We're going to do number 1 and number 2. It says find the mean, median, and mode for each set of data. Round to the nearest tenth if necessary. So if it has several decimal places, you round off to the nearest tenth. So we're going to start off with the mean. Now, what you would do at this point is you may use a calculator. I'm going to let you use a calculator to add up all those numbers. You might want to double check yourself as you're doing it because you never know. So add those all up. Well, I did that earlier. It's 438 divided by, how many numbers are there?
10.
10. What's the rule on dividing by 10? Take off the 0, but there's no 0 on 438, so what do I do? How do I not, there's no 0 to take off, but I'm dividing by 10. What do I do? Don't add, nope, I'm not going to add or subtract a 0. There isn't any. We're not going to add one on. When you divide by 10, you move the decimal one place over to the left. So it would be 43.8. And it says the distance the ball is thrown. Well, they didn't really give us a lot to work with there, but I'm going to say feet just because I have a feeling it might be feet. Okay, the median. The median. So next, I would write all the numbers in order. Okay, so what's the smallest number in the list? Yeah, you got to be careful. It's 19. And then next it would be what?
25.
25.
27.
2 27s.
34.
2 34s.
56.
356. I might run out of space. 1, 2, 3, and also a 104. So I think I got them all. I would go back and double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10, so I'm good. So if there are 10, is there just one in the middle? No, there should be 2 in the middle. And if I count over, it looks like it's these 2. Do I need to add them up and divide by 2?
Yes.
It's the same number. I mean, that's what you're supposed to do, but it's the same number twice. It's just going to be 34. So the median is 34 feet. Okay, mode. Any one there more than any others? 56 is there 3 times, so 56 feet. What?
If there's like 2 of them that are, I mean, would it always be, if they're the same number, would it always be that number?
Yeah, if the median, if the 2 in the middle are the same number, yeah, because if you just added them up and divided by 2, you'd just be doing the opposite there, right? So you can just say it's that number. Yes. Yeah, the median is directly in the middle of those 2 numbers. So if they're the same, you can't go anywhere. It's going to be 34. All right, I want to finish off with number 2 because this is what I was talking about, an extreme value. So the mean is adding those all up. So this is the number of movies seen this month. So somebody had 3, 3, 3, 3, 3, 10, and 3. So if I had to add all those up, what is that, Justin? 28 divided by how many numbers are there, Justin? 7. 28 divided by 7, what is that? 4. Look at that. All of those 3s. And the mean is 4 movies. You see what the 10 did to that? That pulled that all the way up a whole number, even though there were 6 3s in that list. It messed up. It pulled that mean up that much. Okay, the median is just going to have those 6 3s. And then the 10. Is there one number in the middle? Yes. It's going to be this one, and it's exactly what we thought. 3 movies. And then, of course, what in the world's the mode going to be? Definitely 3 movies because it's there the most. Okay, I did that one just so that you could see what happens when there is an extreme value. It pulls the median, or the mean, I'm sorry, one way or another. Are there any questions?